Welcome to the another video on basic electrical engineering. We will do some numerical from the assignment 2. This problem over here where we have got the 30 volt as a source over here and we have a current source, and the question is asked what is the voltage across this current source. The good thing is that we know what is a 6 ampere current is flowing through this 2 ohm resistor, and if it is flowing from 2 ohm resistor we can evaluate the voltage across here is 6 to 12, so 12 volt here. Then we can get the voltage across these two nodes, and we can also get what is the voltage across here and these two nodes. Suppose this is A and this is B, and with this we can get what is the voltage across this by applying a KVL either in this direction or we can get in this direction. So if we want to know what is VAB, we can calculate what is VAB simply by writing VAB over here and plus and minus symbol like this, VAB, and because of the current direction over here we will write the sign convention in this direction, and here because the voltage source is already there, so plus and minus. So in this direction, so how we will going to move, it is up to us. Okay, let us move in the direction like this. So what we encounter first, a minus sign, so minus 6 to the 12, then plus, that is 30, then minus again, minus VAB is equal to 0. So from there we can write from this equation that VAB is equals to, VAB will go there and this is 18 volts. So like that we get what is the value of VAB. Similarly we can, if I know the value of VAB and plus sign or sign over plus and minus like this, so current is obviously going down. So here the current is 6 ampere which is coming in, some current is going down, how much? 18 divided by 9, that is 2 amperes. So if 2 ampere is going out, so here the current is obviously 4 ampere. So now you can see that we can easily find what is the current from the 3 ohms, and also we can get the sign convention depending on the current direction. So 4 ampere is going from A, let us give this name C or any other term, so it is going like this. So let us see the solution of it. We have given a name A, B, C and D. So 6 ampere is flowing in this way, and this is divided here. So here you have a current which is going down is I1, which is evaluated as 2 ampere. So now this 2 ampere is going here, so obviously 4 ampere is what from A to B, 4 ampere is flowing. So I2 is how much? 4 ampere. Because I2 is 4 ampere, we can also calculate VAB. VAB is nothing but 12 volts obviously, and then our objective is to find what is BC or BD, because these are the same. So BD, if I'll say first, it is encountering a like minus 12 is 4 3 is 12, because we are doing B and D. See this path B and D, first minus 3 into 4 12, and here it is 2 into 9 18. So minus 12 plus 18, it comes out to be 6 volt. Remember, first we are taking the current depending on our desired direction. Whatever we want, we give a direction of the current. Now based on the direction of the current, give the sign convention. So if direction is like this from A to B, the sign convention is plus and minus like this. So after the sign convention, apply KVL. So from there we get VBD is equal to 6 volt. So obviously BC is also equals to, this is nothing but BC is 6 volts. Now I3, if I know the voltage between this, so I can get the current which is 6 divided by 1, this is 6 ampere. So 6 ampere is going down, so 2 ampere is coming like this, 6 ampere is going down. Obviously this current is how much? This is 2 amperes. So if I know this is the current is 2 amperes, see this is 2 amperes coming, then this 2 amperes is also flowing from 4 ohm resistor. So we just need to find that this voltage between this and this is known to us, that is 6 into 1, 6 volt is known to us. If 6 volt is known to us, whatever the voltage, this voltage must be divided between that. So 2 into 4, we have 8 volts over here. The polarity is different, this is minus and plus. So just take the value is apply the KVL, then we get V0 is equal to 14 volts. So that is how we get 14 volts. You might be thinking like this is like 6 volts, 6 volt over here, B and C is 6 volt, and but here is a negative voltage, like 8 volt is negative voltage, so this must be higher than that. The 8 plus 6, this comes out to be 14 volt over here. So that is why this is 14 volts. That is how we can solve this problem so easily. Other problem is there. Here is a very simple problem, like what is the value of R given the 2 ampere is given. So we know the current division rule. Suppose the main current is I, so we can write this is I1. Suppose we know that I1 is equal to opposite resistor, it is in parallel, so it is opposite resistor 10 by 10 plus R into the net current is I. So we can also find the equivalent resistance of this, and also we can find equivalent I is nothing but total B by R equivalent. So like that we can, and what we can get is that I value we put, we haven't done any type of calculation earlier, and just take this, cut these two values, and what we get is 1000 divided by 100 plus 20 R. You solve this equation, and what you get is R equals to 20 ohms. So B is the answer. Here another problem is here, you've been asked what is the current I1. So why I will go on solving everything just to KCL, KVL everywhere. So what I will do is, let us take this out, things out, and let us solve this thing. And this looks very easy because 50 and 10 in series, this comes out to be 60. This 60 and 30 in parallel, this tries to be some value, 20 I think, and this 20 will add with 60, again it will come down to be 60. This 60 and this 60 in parallel, this will come down to be 30. So can we just, though these things we can just short it out, and we can write this simply 30 here and 120 in parallel. Our question is find the value of I1. I1 is the current which is flowing from here. Current division rule, 120 by 120 plus 30, 150 into 60. So this is coming around 48 milliamperes. So this is answer is B. Another problem is here. Here you've been asked find the value of V0. V0 is here. So to get the value of V0, you need to know what is the current which is flowing from here. And whatever current is flowing, you must know what is the current here. And at the same time, it is a current which is in is 60 milliampere is given here. So what I want is just remove this two circuit with a single circuit, because these two are in parallel. It will not make any difference, so that you can find what is the current which is going from here, and you can get what is the current this side. So if after removing this current, this thing as 40 now, we have got a current division rule. We can find what is the value of I1 here, but this is 40 ohms. This is not 40 amperes. So 60 is milliampere is a current. 40 ohms here, this is 40 ohms, this is 50 ohms, and this is 10 ohms. So now we have to find out the equivalent resistance. 50 and 10, this comes out to be 60. 60 with 30 will comes out 20. 20 with 60 will comes out to be 60. So what we have is this thing lead to 60, and we have 40. These two are in parallel. So current division rule is opposite resistance. Opposite resistance is 40 divided by 40 plus 60 into the total current is 60. It comes out to be 24. And then you can find, once I1 is known, then again there is a current division, and you can get the value of I2. You get 8 amperes. So that is how the answer is C. That is 8 amperes. Then 8 amperes when multiplied with 10 ohm, it will comes to be 80 millivolts. This is another problem where we have got this is in look like a little bit of bridge type of circuits, and one 5 ohm resistor is in between, 36 volts. So what is asked? The current is 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 asked. What is the current which is going in? So this will obviously you cannot find unless you find out the equivalent resistance of that. So there are many ways to find out the equivalent resistance. Let us take any one of the way, because you need to just know to convert any one of the way to find out the equivalent resistance. So we will eliminate these terms and we will convert into this thing, so that you have got these two in parallel, these two in parallel, and together they are parallel with this one. Now see that we find our equivalent resistance is coming 13.5, this is 27, this is 32.4. So these two, 4 and 13.5, this add up to 3.0857, and these two combine to 6.1714. This is series, and when you evaluate these things, it will come out to be 7.2 ohms, and with 36 volt, the current is obviously 5 amperes. So current is the net current flowing from that entire resistor is 5 amperes. So answer is C, 5 ampere. And this is another problem. Usually when you read the basic electronics, you will be encountered with this type of problems where the circuit somewhere look like this. So just to keep in mind that here the current will flow, obviously the current will flow in this direction, but this is not going to be, this is a node which is connected with another branch element here, but this is not going to connect it with them again. So the current, this current will not be going there, rather it will come back in this flow in this direction only. So based on direction of the current, let us say current is I, so plus minus, based on direction of current, you can have a sign convention like this. Similarly here also, you can have a positive symbol over, you can make the direction like this, or you can make a direction like this. Direction of the current is up to you. You can decide the direction of the current. Now if your answer is right, it will come in positive. If direction is wrong, it will come in negative. So again, you have a sign convention based on the direction of current. So like this, so sign convention done. So how you are going to solve is, you have been asked what is the value of VAB. So VAB, that means obviously you will move from, VAB is asked, so obviously you will move from here. Suppose this current is I1, so you will move from here, this is 4 into I1 will be the current, will be the voltage across 4 ohm. Now here the current is not there, so it is 0, so no need to write, and here you encounter plus first, so 6, again you encounter nothing because the current is 0 here, so no need to write. Again you come out here and you get 5 into I, so you get 5 into I. So that is how you get the voltage across VAB. Let us see the solution. From here we get the current I is equal to 1 ampere, and from here we get current I1 is equal to minus 1 ampere. Now when you write down this VAB, suppose you get a confusion also somewhere, just you can make a dotted line, and because this is negative, you make a small letter, and this is a bigger line if you connect it with a positive. Then you can make a closed path also. See that? You can make a closed path, you can move in any direction. Let me move from here. So that it is coming negative sign. So that's why I keep it minus AB also and make it plus. So I'm saying minus AB, so when equal to, entire thing equals to 0. So that also it is possible. I will write this is minus AB, this is AB, but I'm moving from this end. I will move like this, moving in this way, and then we will move like this way, and after that again we come back to here. So wherever you start, you must reach at the same point. So you apply this KVL in the closed path in the circuit, so it will come out 7 volts. So that is how you can use the KCL. So far we have studied what is the KCL, what is KVL, and Ohm's law. And using this Ohm's law, KCL and KVL, so many problems you can solve. But the only problem is that these are good, and you can solve meticulously, but it makes the problem solving very lengthy. So are there any tricks like node analysis or mesh analysis? Some tricks are there if we're learning in further videos, so that you can solve the same problem much easier and much quicker. So that is how we finishes this Ohm's law and KCL, KVL theory and the numerical part of it. Thank you very much. More things we are going to learn in the next video.